Let's create a simple wallet contract in Sway. This wallet will have an owner. We'll call the function init to initialize the owner. Anyone will be able to deposit. However, only the owner will be able to send the token to someone else. Now in Sway, all tokens are supported natively. What does this mean? Well, in EVM, the only token that is supported natively is ETH. When you write your smart contract in Solidity or Viper, your contract can send ETH or it can receive ETH without any additional smart contract. You just call a built-in function to send the ETH, and you put a keyword payable to accept ETH. However, in Solidity and Viper, no other tokens are supported natively. For example, take USDC or DAI. Your smart contract cannot simply send it or receive it without interacting with the ERC20 contract. However, this is not the case in Sway. In Sway, all tokens are natively supported. So you can send your custom tokens as if they were native tokens. Sway assumes that there will be one native token, and this is called a base asset. And the ID associated with this base asset is called base asset ID. So what we're going to be building is a contract that receives and sends the base asset. So the first thing that I'll do is import the errors that we're going to be using for this contract. So here I've already declared some errors, and to import and use it inside our main contract, what we're going to do is type mod errors, and then to actually use it, we'll say use : errors : curly braces, and the errors that we're going to be using. The errors that we're going to be using are access control error, deposit error, and init error. Next, we're going to import some standard libraries that we need. The first one will be message.sender. Say use std : alt : message sender. We're also going to need some libraries to handle token transfers. So say use std. And to get the asset ID, the asset that was sent, we'll import call frames : message asset ID. We'll also get the constant base asset ID, constant base asset ID, the amount of token that was sent, context, message amount, and to transfer the tokens, we'll also import the function transfer, token transfer. This transfer function is like the transfer function inside Solidity or Viper. Both in Solidity and Viper, you can only call the transfer function on ETH. However, in Sway, we'll be able to call it on any token. This will include the base asset and any other token that we create. Okay, so these are the imports. Next, I'll declare some state variables, say storage, and the only state variable that we're going to need is the owner of this contract. Owner, option, identity. Identity means that this owner can either be a contract or an account. Option, none. We'll initialize it to option none. Okay, next, let's actually implement these functions. The first one, the easiest one, will be a function that will get the current owner. Notice that this is storage read, so this means that it's only going to be reading the value from the storage. Say storage.owner. Before the contract is initialized, storage owner will be none. After you call the function init, this storage owner will be message.sender, the account that called the function init. Inside this function, we'll check that initialize has not been called yet, and then we'll set the owner to message.sender. Say require storage.owner.is none. And the error message that I'll put in here is the custom error message init cannot reinitialize. So over here, say init error cannot reinitialize. Next, we'll get the sender. Say that sender is equal to message sender. This is a function, so we'll call it. And we'll check that this function returns successfully by calling onWrap. If for some reason message.sender cannot be retrieved, then this part of the code will fail, so this function will fail. And once we have the sender, we'll set it to storage owner. Storage.owner is equal to option : sum sender. Okay, that completes the init function. Next, let's write the deposit function. So notice that the deposit function is read, write, and it's also payable. This means that we'll be able to send tokens when we call the function deposit. We'll first check that this contract is initialized, meaning that the owner is set. Say require storage.owner.isSum. And for the error message, I'll use not initialized. Init error : not initialized. Okay, next we'll require that the token that was sent is the base asset. So say require message asset ID is equal to base asset ID. And the error message that we'll use is deposit error, not base asset. Deposit error, not base asset. Okay? The last check that we'll do is that the amount that was sent is greater than 0. Say require message amount greater than 0. And the error message, deposit error. Which deposit error are we going to be using? We'll use the error 0 amount. 0 amount. Okay, and that completes the function deposit. Okay, let's move on. So the last function that we'll implement is send. Only the owner of this contract will be able to call send to send the base asset to someone else. To check that the caller is the owner, we'll first get the sender. Let sender equals message sender dot on rep. Okay, next we'll require that this sender is the owner. Require sender is equal to the storage owner. Storage dot owner dot on rep. Storage owner can either be none or some identity. If it is none, then unwrap will throw an error, so this function will fail. So this part of the code will only be successful if there's some owner. And what error message are we going to be using? Let's use access control not authorized. Access control not authorized. Okay, at this point, we know that the sender is the owner of this contract. So the last step is to send the base asset to the to from the input. To do this, we call the function transfer that we imported from the standard library. Transfer. Transfer the amount. The asset that we're sending is the base asset ID, and we're sending it to, and that completes the send function. Now notice that this transfer function is something that we have not seen in Solidity or Viper. In Solidity and Viper, we have a built-in function called transfer, but we can only send if. However, this transfer function inside Sway will be able to send any tokens, including the base asset. So this is what I mean when I said that Sway supports all assets natively. In Solidity, if you wanted to transfer a token other than the Ethereum, for example USDC or DAI, then you would have to call the ERC20 contract. However, in Sway, we can just call the built-in function transfer. Okay, and that completes our wallet. Let's try compiling this contract. Inside the terminal, I'll type fork build. Okay, there's a missing semicolon, so I'll go back, put a semicolon here. Let's try compiling the contract again. Okay, and our contract compiled successfully.